In this video, we are going to solve this problem. This problem is from CSIR NET December 2017 Mathematics. And this problem is very easy if you do the explicit calculation, the matrix multiplications. But you will see why this problem is interesting, why we are considering this problem in particular. So let the given matrix be A. So A is 0, 1, minus 1, 1. This is the given matrix, and one has to check whether A power 1, A square, A power 4 and A power 6 is equal to identity. One of them is equal to identity. One has to find this. A power 1, which is A, is not identity, so this option is incorrect. Now of course one can solve this by just finding the matrix powers, that is A power 2, A power 4 and A power 6, and one has to check whether one of them is identity. But those matrix multiplications involves huge calculations. Now I want to mention that people are uploading videos on YouTube solving this problem just by doing matrix multiplications, that is calculating the powers of A. But in the exam hall, it is highly possible that you will make some mistakes while doing all those matrix multiplications. Therefore, we will try to avoid the matrix multiplications and we will find some analytical approach to solve this problem, where you will be able to see that the chance of making mistakes is really less. You cannot make any mistake here. So for that, first we need to calculate the characteristic polynomial of A, which is char A is the notation, is equal to, if you just calculate it, it's very easy to calculate, x into x minus 1 minus 1 1, which is nothing but x square minus x plus 1. This is the characteristic polynomial. And if you see, the minimal polynomial of A is also x square minus x plus 1, because minimal polynomial of A always divides the characteristic polynomial of A, and you see this characteristic polynomial here is irreducible. That is, you cannot write it in the product form x minus A, x minus B. You cannot write it. So if minimal polynomial of A divides the characteristic polynomial, which means this polynomial x square minus x plus 1, then minimal polynomial is that only, because that is the only polynomial which satisfies this polynomial, because there is no such factor. So minimal polynomial of A is x square minus x plus 1, and it is well known that if Px is a polynomial and P of A equal to 0, then minimal polynomial of A divides Px. Now the problem, if A power n equal to identity matrix, this implies A satisfies x to the power n minus 1, this polynomial. Now minimal polynomial of A is x square minus x plus 1. So this polynomial should divide x to the power n minus 1 clearly, because minimal polynomial A divides all Px such that Pa equal to 0. Now for which n x square minus x plus 1 divides x to the power n minus 1, that should be the answer. So for which minimum n? So n equal to 1 is of course not possible, as we have seen already, because A to the power 1 is A is not identity, and here also if n equal to 1, then x to the power n minus 1 is nothing but x minus 1, and x square minus x plus 1 cannot divide that. Now n equal to 2 case. So n equal to 2 case, in this case x to the power n minus 1 is x square minus 1, and clearly this polynomial does not divide x square minus 1, so this is also not a possibility. N equal to 3, n equal to 4. Then it is x to the 4 minus 1, which is x square minus 1 times x square plus 1, and clearly again this does not divide. So this, and now we are sure as only one option is correct, n equal to 6 is the correct answer. But for n equal to 6, we want to check whether this polynomial actually divides x to the power 6 minus 1. For that, if you see, x to the power 6 minus 1 for n equal to 6 is nothing but x cube minus 1 into x cube plus 1, which is again x plus 1 into x square minus x plus 1. So you see this factor here. So x square minus x plus 1 divides x to the power n minus 1 for n equal to 6, and therefore this should be the answer of this question. And you see, there is no matrix calculation involved. There is no calculation actually. This is just analytical approach, and there is no chance of making mistakes here. And therefore I will basically prefer this method of solving this problem.